Okay, next kind of projectile motion is when it's launched at an angle. Okay, so we're going to have this thing, flat surface, it'll get launched like this. You'll have some sort of an angle here. So I'm going to tell you that we're going to throw a baseball or something like that. It's going to be thrown at 30 degrees. I'm going to tell you that this baseball, it leaves at 100 meters per second at 30 degrees. And we want to find two things: maximum height, and range. Okay, those are our two values. So if this is 30, right away we know that that's 30. We know that it's symmetric, so time to the top is time to the bottom. We also know that this VIY is 0 meters per second. And we know gravity is acting everywhere in the y direction at -10. So let's start with what we'll always start with. We're going to find Vx. That's going to be 100 cosine 30 degrees. So your Vx is going to end up being 87 meters per second. And your VIY, and the reason why I don't call it VIX is because, remember, it's the same everywhere. So I just call it Vx. But my Vy, that's just the initial velocity right there. That's 100 sine of 30. And that ends up equaling 50 meters per second. Okay, so this is going to change. It's going to change from 50 to 0, and then it's going to go from 0 back to -50. And the time is also going to be symmetric. So we have our two values. Next thing we want to do, I want to find how long it takes to get to the maximum height. So I want to find t to the maximum height. That'll get me my time parameter there, which will tell me my total time, and I'm basically going to use this for everything. So my time to my maximum height. So really what's happening in this situation, if we look at it in total x and y motion, really x is doing that, so that's my x motion, and my y motion is going up and coming down, and that's my y motion. So I'm going to identify which one of these two dimensions is going to help me out the most. When I put them together, it looks like this. Time to maximum height, I'm going to use this one here. I'm going to take the fact that my VI in the y direction, my value right here, I figured that out as 50 meters per second, and I know that my V final in the y direction is 0. I'm going to use those two, and I'm going to use the fact that gravity is -10 to go VFY equals VIY plus AT. My VFY, 0. VIY is 50 minus 10t, so that means that time ends up equaling 5 seconds. That's to the maximum height. So now I know that the time to go the whole entire range is 10 seconds. But I'm going to use this to find the maximum height. So I'm going to use t equals 5 seconds to find the maximum height. How am I going to do that? Well, I have time, so I'm going to use my dy equals VIT plus 1/2 AT squared. Am I going to use that one? No, that's not going to work for me. But I picked it anyways. I'll show you why it's not going to work. I want my dy. My VI, oh no, this will work. What am I talking about? My VI is 50, right up here. So put that in. 50. My t is 5 plus 1/2 minus 10, 5 squared. So let's see, that's going to end up equaling on 50 times 5. Okay, that's 250 minus 25 times 5. 125. So my dy ends up equaling 125 meters. That means that's my maximum height. This is 125 meters from here to here. My only concern about using this equation was that had I taken my total time frame, because it just gets to the top in 5 seconds. Had I used 10 seconds here, my dy would have been 0, because I start here, 5 seconds later I'm there, so that's that 125, but 5 more seconds, I'd have gone another 125 down, so I'd have had dy equals 0. Try it. Put a 10 there and see that. That'll end up being 0. And that's not what you wanted. So let's see, I got my maximum height. Well, now I want my range. So my fourth thing, I'm going to use dx equals vxt to find range. Remember, this is actually plus 1/2 at squared, except there is no acceleration in the x direction, so that goes to 0. So really it's just dx equals vxt. My dx is my range, I want to find that. My vx, 87. And when I put my time in, I can't use this 5 because that only gets me to here, which means I'd only find half my range. So I want to use 10. So my dx, my range, is going to be 870 meters. So that's my range. So that's right here. 870 meters. There you go. Those are launched at an angle, on a flat surface, perfect symmetry,